Okay, and I guess it's 6 o'clock now in Paris, probably 7 in Greece and 5 in Ghana, 6 in Serbia as well. So we'll get started, even though there might be a couple of people who join in. I'll introduce things at first and give everyone who wants to say hi and introduce themselves a chance to introduce, so we know everyone who's at the meeting and checking out the experiments. And then I'll turn things over to Serbia to start things with experiments. So I already know most of you already, maybe not everyone, but I'm Michael Gregory in Paris, France. I'm the founder of YES. I founded it as a science club at my own school in Paris. Unfortunately, I don't think even any of my own students are joining me today, which I'm rather disappointed with. But that being said, last year in Ghana, both with Samuel and Kapasa, who's joined us, and Chris, who's joining us from St. Francis College of Education, and I see him just connecting right now, we started holding YES international meetings to exchange experiments between our countries. So just to explain that to anyone who's new to the project, it started out that we'd rotate 1 week. It would be my students in Paris, another Samuel's students in Kapasa, another Chris's students at Ho International School, both in Ghana. And we wanted to invite more people along. So I think Maria was probably the next person I invited in October or so. But it's been tough coordinating having multiple people for it. So today is the first attempt at an open YES International meeting. Open in the sense that, as most of you know, it's open for anyone who wanted from any school to sign up to present some experiments. So we'll be starting with some from Serbia, then moving over to Greece, hopefully having the 2 people from Turkey who signed up to join experiments join. I don't see them here yet. And then finishing off with Chris's students. And today will actually be College of Education students at St. Francis College of Education in Ghana. So that was a brief introduction to the project. Of course, if anyone has any questions, anything that they want to ask me or anyone else, please feel free. And just before we start experiments, can anyone who's not shy and wants to jump on the microphone, if you can with your camera as well, just say hi, introduce yourself, so we know who all's joining us and we know who we're sharing experiments with. So in no particular order, anyone who wants to say hi, please start saying hi.
No.
Hi.
Hello, so that sounds like Gordana and her students in Požega, Serbia saying hi, right?
Yes.
Perfect. So it's good to see you. Good to see you ready. Does anyone in Ghana want to say hi to the group as well? And I see Samuel waving. Your microphone seems to be off, but we're getting that you're greeting us and saying hi. And I think with a couple of the other teachers, and Godwin is with you as well, right?
Yes, Godwin is with me here. Hello,
Excellent.
can you hear me, guys?
Yeah, I can hear you. It's a little faint, but we can hear you okay.
We wanted to say that unfortunately we need to finish this till 6:30 because of our school schedule.
Okay.
Okay, so we'll skip through the introductions quick and we'll get to your experiments. Chris, did you want to say hi from Ghana as well before we get to the experiments? Let's move on to the experiments in the interest of time, and when we get to different people with experiments, we'll let them introduce themselves a little bit more. So without further ado, turning things over to Požega, Serbia. Thank you for joining us. I'm looking forward to seeing your experiments.
Hi, I'm really glad to see you all today. My name is Dunya B. This is Dunya R. And here's my physics teacher and math teacher. We wanted to show you a few ways how you can determine the value of pi. And we're going to start with our math teacher showing you how to visualize the number of pi from the model way.
It is not especially modern. It was found in 1849, some 117 years ago, but still very effective, and we can visualize the number very, very precisely. To this, we need the one segment with length of 1. Next thing to do is to construct a perpendicular line to the B. Then we construct the circle. Radius 7.8. Define the intersection of those two. Next, we construct a circle with the center of A and the radius of AB. And the intersection of that with the AB is F. Next, we construct a perpendicular line F and AB. And the circle of length 1/2. Intersection is H. And we draw lines with A is H. Construct a perpendicular line from F to NH, A to H. The intersection is I. Connect I and B. And draw the perpendicular line, now we draw the parallel line from H to AB. Now, the segment BJ, this segment BJ is decimal part of pi up to 6 place, 6 decimals. In 8049, look now, we'll construct the circle, the center is B, and the radius is pi minus 3. So look how close it is. Look how close that J dot point is to the circle. It's on the circle. When we zoom it enough, decimal place. 5 decimal place still there. Now we see some difference. Look how small difference from that to 80.9. That's it. Thank you.
Thank you so much. Now our classmate is going to show you, tell us something about the history of number pi. And we wrote the history of number pi all over the classroom. And we wrote as well the 1,000 digits of number pi also all over the classroom. Okay, so now Antonina is going to tell you something about the history, and with Sandra.
Hi, my name is Antonina, and we're going to show you the history of number pi. The ancient Babylonians calculate the area of the circle by taking 3 times square its radius, which gave a value of pi, which equals 3. One Babylonian tablet indicates a value of 3.125 for pi, which is a closer approximation. The first calculation of pi was done by Archimedes of Syracuse, one of the greatest mathematicians of the ancient world. This symbol was explained with mathematician William Jones in 1706. And you have digits here, and that's it. Thank you.
Okay. Now we're going to do the peak experiment. Here we have a plane surface of circle and the square, and we're flashing the number of dots and the ratio. Number of dots in square is 80, and number of dots in circle is 60. So their ratio equals 4 to 3. We can find number p from this formula. Because the ratio of their surfaces equals to ratio of the number of dots in square and circle. Thank you. So the next experiment is the surface tension experiment. Here we have a surface tension formula. This is the formula for surface tension. This is a weight of 1 water drop that drops out of burette. So the weight of 1 drop is equivalent to 2 diameters times pi times this constant here. We have the values here, and when we calculate this formula, it should approximately be around 3.17. This is also the same formula, as you can see. Okay. So the next experiment is surface ratio here. So here we're gonna find the ratio between square surface, which is here, and the circle surface. As you can see from the picture, this is the edge of a square, and this is the diameter of a circle. As we can see, one edge is equivalent to two circle diameters, and this information we're going to use in this formula here. So those are the basic formulas for surface of a square and circle. So here, this is the value of number pi. Number pi times diameter squared is divided by 4 circle diameter squared, and when we calculate this, it should approximately be around 0.78. Okay, the next one is here. They're going to explain it to you. This is mathematics pendulum.
Here we have the period that is equal to one full oscillation, and it's equal to a whole time of oscillations divided by the numbers of oscillations.
Our formula is that the period of one oscillation is equal to 2 pi times square root of length of pendulum divided by gravitational acceleration. In our example, we have that length of pendulum is equal to 0.5 meters, and the gravitational acceleration is always 9.81 meters divided by square seconds.
The whole time is 14 seconds, and the number of oscillation is 10.
Using this formula, we got that P is approximately 3.02. Thank you. So the next experiment is experiment with shoelaces, and my friend is now going to explain to you.
So here we have actually P, that is actually the hypotenuse. So the circumference of the circle is equal to hypotenuse times pi, and because pi is approximately 3.14, that actually means that the circumference of the circle is equal 3 times the hypotenuse. So, and we can prove that, but by in this in the experiment, by using just one shoelace.
Thank you. So the next experiment, the way we can determine the value of pi is by using a cylinder. So this is the formula for a volume of a cylinder. As we can see, first we can measure, we already measured, but we can measure the volume of a cylinder, the diameter of a cylinder, and the height of a cylinder. And when we calculate all those, when we calculate this formula, we would get approximately the value of pi, which is 3.139. Okay, so the next one is so this is the next one. This is experiment with surface and square ratio and with net. Okay, so we got the net here, and what we're gonna do is we have the dots here, and we are measuring how many dots are in this big square and how many dots are in a circle. So when we measure that, we have 120 dots in the square and 90 dots in a circle, which is when we divide it, it's 4 to 3. And when we put it in a formula, we have here, there's when we divide these two, we got 4 to P, and P is approximately 3.14, which is also 4 to 3. Okay, thank you. I just wanted to say, in my opinion, this one is the most interesting. This is again the experiment with surface tension, which as you can see, my friends already did the experiments before and got the values here. So we use the spring and the burette. Okay, I just wanted to show you this. And we can film again the whole history that we wrote on the wall. And under the history, you can see the thousand digits of number pi. Thank you so much for being with us in class. This is everything, and give me free to do. Bye.
Oh, that's really beautiful. That's a lot of different experiments to see. I'm jealous. My students at my own school didn't come up with quite so many. So that's really wonderful to see. Are you guys okay to answer a couple of questions if anyone else has questions about any of the experiments you just showed?
Do you have any questions?
So I have a couple of questions I want to ask, but also if anyone else has any questions, if you're okay answering them, then anyone please jump in, preferably with your microphone, if not in the chat, and I'll relay questions. I was wondering, could you explain the surface tension one again? Because that one was new for me, and I didn't I didn't fully understand it. Would you mind going over
our
it quick?
teacher is now gonna explain it to you. Okay. Here.
Okay. Держу щітку бородити. Окей. Ні, так тепер гліцерол. Що ти гліцерол? Де це? Ось гліцерол. А держи все.
Okay, so we poured water, and now we're putting the spring on the surface of the water. We're pouring the glycerol.
In this small cup. Okay.
Yeah.
And now
Putting spring inside. And so the tension is releasing the water in the cylinder. You see? This water from this cup is transferring in the cylinder.
So, but
And
it's
here's the formula for this. Sorry. As you can see.
is the first mass the mass of the glycerol, or is it the mass of?
The first mass is the mass of the spring ring, of the hook.
Oh, okay. And so
What?
I'm just trying to understand it still. If it's clear for everyone else and it's just taking me a minute to understand, please feel free to jump in and say and I'll just think about it more afterwards. But so is the spring to measure the surface tension, or is it adding? Yeah, what is the spring doing?
So this is the mass of the spring, which is of the ring. Sorry. So the mass of the ring. Here we have a weight, and because of weight, the water is pouring from the. Oh my God! Sorry, water is pouring outside. Arthur is gonna explain it better to you. Sorry.
Yes. Result.
This is the result, and this is the spring.
Gravitational. And this is surface tension, you know.
Surface tension that is going downside. I hope that now you understand it a little bit better.
Oh, okay. Yeah. Yes. Thank you. For me, it's a lot more clear now. But anyone else who, if you need to ask more questions, please don't be shy to ask more questions. So it's that the ring is making it so there's a specific surface of water that's in the ring, and there's an upwards force, like because the surface tension is pulling downwards, or the ring is exerting an equal and opposite upward force.
Yes,
And
exactly.
that's proportional to the area of the ring, which is where pi comes in.
Yes.
And then just to make sure I understood, when you added the glycerol, was that then to get rid of the surface tension, and you were measuring a difference in force there?
Mogli bismo smatrali da je poznato pi, a onda smo merili ovo. Zašto smo stavili gliceri? Aha, možemo li se voditi?
You can actually pour water with whatever liquid you have.
Zavisi šta nam je nepoznato. Znači, jedan smo mogli da imali da smo ovo znali.
Okay, and it'll have a different coefficient of surface tension in that case.
Yes, the surface tension would be different if there was an anything.
Okay, beautiful. I really like that one. And all the others as well. Does anyone else have any questions for them?
Apparently no.
It doesn't look like we have any more questions, so we'll move on. But that was a really beautiful set of a lot of different experiments. So well done, and thank you.
Thank you so much. Bye.
And so now we'll move on to Greece, where Konstantina has prepared an experiment. So Konstantina, when you're ready, please, the stage is yours.
Hi. So in the experiment I'll be presenting, I will use the formula that gives the volume of a sphere. I will use this one to get an experimental value of pi, and then I will calculate the error between theoretical, which is approximately 3.14, and the experimental value of pi. So I'll begin first of all. I have this sphere, and I need to find the radius. But because it's impossible to measure it, I will firstly find the diameter. I will use this caliper to find the diameter of it. So I'll just open it here. And so as I see here, the diameter is about 2.266, and then now so I'll divide it with 2 by 2 to get the radius, which is now 1.133 centimeters. Now I'll use this volumetric tube to find the volume of it. I'm gonna add like 20 millimeters of water. That's about it. And now I'm gonna drop in the bowl and see how much the level of the water has risen. So it has risen about 6.5 by 6.5. So the volume of the sphere is 6.5 cubical centimeters. So the volume of the sphere is equal with 4/3 times pi times radius cube, which means that pi is equal to 3 times volume divided by 4 times the radius cube. So this equals to 3 times 6.5 divided by 4 times 1.133 cube. It's equal to 3.35, which is the experimental value of pi. As we all know, the theoretical value of pi is 3.14. So now I need to find the error between them. So in order to find the error, I need to subtract the experimental minus the theoretical value and divide the result with this theoretical value and multiply it by 100. So the error is just 6.6%. That's it. Thank you.
Excellent, thank you. Does anyone have questions for Konstantina in Greece before we move on to another experiment? Doesn't look like we have any questions. That was beautiful.
Great.
I really like that one. Thank you, Konstantina.
Thank you so much.
So moving on the schedule, we have two from Turkey, from Muhammad and from Merem, but I don't see them in the room. So unless you've joined with a different name, please let me know. Otherwise, if they're not here, then we'll be moving on to Ghana with Chris at St. Francis College of Education. Chris, are you still with us? And are your students ready? I see Chris still appears to be there, but we're not getting an answer from him. I'm just going to send him a text to make sure. Sometimes the connection there is bad. Okay, so hopefully Chris and the students at St. Francis College of Education will be joining shortly. That should be the last of people who signed up to share experiments. If anyone didn't understand the system of signing up and has something to share, if you want to jump on quickly while we're waiting for Chris, just let me know if you have something to share that I didn't know to include in the schedule. Otherwise, just to buy a tiny bit of time while waiting for Chris and the students of Franco to hopefully join. Fun fact, I was actually at St. Francis College of Education only a week, just over a week ago during my last trip to Ghana. And as I mentioned at the beginning, Chris was one of the founding members of our Yes International meetings. Okay, and he's texting me to say they're ready, but the network's terrible. So now that they know that we're waiting for us, hopefully they'll be able to come back on. Sorry for this delay, and thank you everyone for your patience. So yeah, as they're sorting things out, are there any questions anyone has about any of the experiments we've seen so far, or about Yes International meetings in general?
Michael, can I speak?
Yes, please do. Yes, thanks, Maria.
I think that these meetings are very important. And so I think that I have some students that they want to participate also. So if you expand, I don't know in which, how you can do it, but maybe if we know that we can prepare, for example, something for this subject, I think that is that would be very nice for us. So if we know that we have to prepare, for example, for something like for the thermal energy or something like that, I think that we can participate again, because students are a little bit shy. So I don't know if we will have many contributions from us. But I think that we like
it. That's great to hear, and also very useful, that suggestion of having specific themes. And please, anyone else jump on to let us know what you think of that. Because one thing I sometimes worry about setting a specific theme is that then students or really anyone, students or teachers who have an idea for an experiment that doesn't fit within the theme, they might be frustrated not to be able to do it. But it's true, if we just say anything in science, it might be way too broad for people. So two potential themes. And there we have Chris. So we'll flip things over to him very shortly while the network is still working well enough. Just to say two potential themes that I've thought of coming up, and let me know if you'd be interested in these as themes. One is to try and share some experiments for Earth Day coming up the 22nd of March. So that's like a very specific theme on earth sciences or environmental issues. And then another one that came up, some people actually here in this meeting were part of a Magic of Science event we did on Zoom with some of Chris's students, not at Franco and Hopeway, but in Ho in Ghana. And they want to repeat some of those magic experiments just to show the science behind what appears to be an illusion. And that could be a fun way to get more people involved. Yes, hello, Chris. Yes, we can hear you. So let's switch over to you. Anyone feel free to say what you think of Magic or Earth Day's themes later on after we see Chris, but I'm not going to keep talking while things are working for
my students
Chris and
are
his
ready now.
students.
Say hello.
Hello.
Hello, welcome. Good to see you. So some of you I think I saw in person 2 weeks ago.
Yes.
Yes, I'm Gertrude Atta. I'm happy. I'm a Damebe.
I'm Christian Jakpasu.
I'm Joy.
And I'm Bete Erico.
I'm Ikuti Emmanuel.
And I am Chris. Hello.
Hello, great to see everyone. It's Franco.
Yes. Okay. So.
Good to see you too. Okay. Our experiment is on by using equals. So we have this three instruments, three objects here, A, B, and C. So with this, we are going to determine pi. So first, we are going to find the diameter of each of the objects, as well as the circumference of the object. And with those two dimensions, we'll find pi. So we are going to start with A. So finding the diameter of A.
With the help of a vernier caliper. So we ensure that it is tight to the circumference of the thing to get an accurate measurement. So we are taking our measurements and reading on the vernier caliper.
The 6.5.6. 6.6. Yeah. You know how I do. So A is 6.5.
8.5
yes. Centimeters.
So I will be taking the circumference. So I wrap it around 3 times.
7.6.
Then mark it. Mark it for me. Draw the line. Now I'm taking the measurements. first one 20.7, second, the same 20.7, then the third one 20.3, but I'll be taking 20.7 because it's okay more twice, so we'll be taking that one for the circumference.
14.
Yeah, A, 7. Then we are now going for B.
So I'm taking the diameter of the second object.
That is the B.
So it's now 7.6.
Diameter 7.6.
Measuring this again. This is 24 centimeters, first one. And the second one, 24.
So we'll go on to take the diameter of the third pin. So that's pin C.
Okay. So it's 10.2. 10.2.
0.2. And then as well as the circumference. So we are using the wire to measure each circumference. So we mark about three, we take note of 3 dimensions. And then with that, we take the consistent one. So with the wire, for instance, we use it to, you wrap it around the thing for, let's say, 3 times. So this here, this is the first round. Then the second round. We ensure that it's tight so that we can get accurate measurements. We did it about 3 times so that we can get accurate and consistent dimensions. That's why.
So the third one is 32.0 centimeters.
So now, we divide the circumference by its corresponding diameter.
The first one is
So the first one will be 5.
3.164.
Now give us the second one. 24 divided by 7.6.
3.157.
3.157. The third thing. 32.0 divided by 10.2.
3.137.
3.137. So now we are going to find the average of these three dimensions here. So the average is what? The sum of all this divided by 3, because we have 3 dimensions here. Okay, so the average for this is 3.153. 3.153 centimeters. So we all know the 40, and from our exercise, so a difference of 0.01. And we all know that in experimental setup, there could be little errors and parallel errors and stuff. So with this, there should be a range of plus or minus 0.1. So this is our answer for pi by experimental.
And also, the reason why we are dividing the circumference by the diameter is that we all know that the circumference of a circle is given by pi d. So, making the pi the subject over here, we have circumference to be equal to pi d. So, making pi is why we are having c over d over here, just to help us to get the value of pi.
So we've come to the end of our experiment, the determining of what? Pi, by using circumference equals pi times diameter. Thank you.
Hello, Michael.
Yes, that was beautiful. Thank you. And the quality of the connection sometimes wasn't great, but I think it was good enough that it was clear everything that was going on and what we saw there. If I'm wrong on that, if anyone has any questions for them, either if you couldn't hear with the connection or if you have any questions about how they did that, please feel free to ask them any questions you like. One idea I like sometimes doing, if I get enough data with that circumference and diameter, is to make a graph. So you can actually have the slope of the graph will give you a value for pi. So if you're trying to get students used to the idea that you can get a physical constant from the slope of a graph, that's one of the easiest ways to lead into that kind of concept. Does anyone else have anything to either suggest or ask about anything that we just saw? And it doesn't look like we have questions. Like I mentioned before, as long as I understood who was signing up for experiments, I believe we've seen everyone who showed up. But if I missed anyone, either if you planned an experiment and I just didn't understand how you filled out the sign up form, or if you're one of the two from Turkey who I didn't see in the room earlier and you're here with an experiment, please let me know so I don't not include you if you have something ready. With that being said, and like, please jump on if you do have something either to share or something to ask. Doesn't seem like anyone's manifesting themselves. So I'd like to thank everyone again for the experiments they shared. Just before Chris went on, we were sharing ideas for upcoming YES International meetings. And so it had been suggested that maybe if we have specific themes, then that could make it easier for students to work towards a specific theme and prepare an experiment. I'm very eager to take suggestions if people have suggestions or requests. As I started saying before, there's a couple of themes that come to my mind that I know I'm working on experiments with my students for that could potentially be good. One is Earth Day coming up, April 22nd, if people are interested in celebrating that. Another one is the magic of science. There's a great session that Paul, who I think is on the session today, and Astrinos led for Chris and myself at a school we visited in Ghana at Ho International School, who's one of the founding members of YES International. They either want to present a whole meeting on that, or at least part of one. So if other people have magic experiments they want to show how there's science that could be interpreted or could make an illusion or appear magical, but you can explain the science behind it, that could be a great one. And then my students at my own YES Club in Paris, they're working on a lot of experiments to deal with light, how light works. So if anyone would be interested in contributing to light, then that would take the pressure off my students for having enough experiments to fill a whole meeting. If anyone has any other requests for ideas or themes or anything they want to suggest while we're here together and could share ideas for that, please let me know. If anything comes up afterwards, please email me. I hope that everyone enjoyed the experiments that we saw today and the chance to share experiments. So I hope everyone will come back for others. Does anyone have any questions, suggestions, or anything they want to say before we conclude and say goodbye? It looks like probably no one has anything to say. So I'd like to conclude saying thank you again to everyone, and I hope to see all of you soon. I'll send out ideas or information on upcoming meetings. And like I've said to everyone, both by email and I think I mentioned in person, anytime that anyone's ready and wants an audience to share experiments with, let me know if you're ready to share a whole meeting, and I'll invite everyone I know, and this is roughly who might show up, or if you want to contribute 1 or 2 experiments at a time for another open YES International meeting. Like I said, I've got a couple ideas for themes, and I'm very happy to take suggestions. So with all that being said, unless anyone wants to jump in, say anything else, I'll say thank you again, everyone, both for joining us and for sharing experiments, and have a great evening, everyone. Happy Pi Day.